Alright, the final section in Chapter 20, 20.5, Forecasting Weather. Now we only have one vocabulary term, station model. Make sure you have that in your lab notebooks as well before we begin. Now we'll have several lab activities and map activities to support these sections for this chapter. So even though we might be taking notes, we're going to learn more and more about each one of these characteristics and each one of these sections in those activities. Now objectives. Compare and contrast the different technologies used to gather weather data. Analyze weather symbols, station models, and weather maps. Then describe how weather forecasts are made. Key idea here is to prepare accurate weather forecasts, meteorologists must gather, distribute, and analyze huge amounts of atmospheric data. Now, using satellites, weather balloons, weather stations, radar, airplanes, and ships, meteorologists must gather huge amounts of data in order to make their predictions. And even then, their predictions typically change depending on how those conditions change. They rely on sensing instruments and on computer models to provide the information they need. Radio sondes are instrument packages attached to a weather balloon. It measures temperature, pressure, and humidity at different altitudes. Now, to help fit the huge amounts of data onto a map, scientists developed the station model. Now, station models include information on temperature, dew point, weather conditions, wind speed and direction, barometric pressure, and cloud cover. That is a lot of information. You put those in computer models and you can analyze it. Now, you can also receive information via satellite, visible satellite image like you see here in Ohio, or infrared satellite image. You change the lens and you can get a different reading of the same system. Now, a station model. Let's break this down a little bit. On the top, it kind of breaks down the actual station model. So the station model is considered this whole entire unit up top right here. So let's break this down. First, we have wind direction and speed. That's this little flag right here. Now, that flag points in the direction of the wind. So this would be northwest, and then depending on the type of flag it has, it will tell us how fast that is. And we'll talk about speed in a little bit. Now, in the center, there's usually a circle. Now, if that circle is open, you see here amount of cloud cover, that means no clouds. 5/10, about half of it is cloudy, and then completely overcast. Now, sky obscured typically means that that weather station could not get a reading. So in this model, there is complete overcast. Then over here on the side, we have temperature, we have precipitation or type of weather, and then we have dew point. So its temperature is always above the dew point next to the weather symbol. Over here we have air pressure, and then we have how the air pressure has changed in the last 3 hours. So the wind direction again, you see if it goes straight up, it's north, and then it follows each of the compass readings all the way around. Now the wind speed. If there is no long line, conditions are calm, as you can see right here. Each bar on the line represents 10 knots. Now if there is no bar, it's between 1 and 2 knots. Each little bar, about a half a bar, is 5 knots. So a full bar would be 10. Then once you get up to 50, a triangle is 50 knots. This would be 55. It's a triangle plus a half. Now the weather symbol. Weather symbol that goes just to the left typically of the station model. We have a symbol for drizzle, rain, smog, hail, thunderstorms, hurricane, rain showers, snow, sleet, freezing rain, fog, haze, snow showers. So we have a symbol for every single type of weather that you can imagine, and it'll be plugged into the weather station. Now, meteorologists use the data to make surface weather maps. Official U.S. weather maps are produced every 3 hours by the National Center for Environmental Prediction, NCEP. So you can see here, I know it's kind of small, but you can see here, there's a weather station model here, a station model here, station model here, station model here. You get the idea. There are station models, hundreds if not thousands of station models around the United States, some larger than others, and they all report to the NCEP. And then the NCEP updates every 3 hours a large weather map of the entire United States. Now, in locating fronts, meteorologists apply these rules. First, they look at wind direction changes behind the fronts. So you can see here, remember we have a large front running all the way across here. This is a cold front. We have a stationary front. We have another stationary front right here. We have a warm front, stationary front out here, and then an occluded front. So they update this map every 3 hours. Now the temperature changes sharply across the fronts, and we're looking at dew point changes sharply across the fronts. So anytime you see a wind direction change behind an air mass or an advancing air mass, which is a front, temperature changes sharply across the front, or dew point changes sharply across the front, those are some of the rules in locating a front. Okay, let's overview Chapter 20 one time before we end our Chapter 20 screencast. We began talking about air masses and weather, origin of air masses, the type, CA, CP, MP, MT, CT. Then we went into fronts and lows, what a front is, the different types of fronts. We had cold front, warm front, occluded front, and stationary front. Talked about the upper airflow of a mid-latitude low pressure system and how weather associated with pressure systems. Thunderstorms and tornadoes. Thunderstorms, briefly talked about lightning and some of the dangers of lightning. Talked about how a tornado forms, the effects of tornadoes, possibly even predicting tornadoes. Storm and tornado watches and warnings. We went into hurricanes and winter storms, how hurricanes form, the effects of hurricanes, how to stay safe, hurricane watches and warnings, and then winter storms, how to stay safe during winter storms. Forecasting weather, gathering data, use of satellites, radio sondes, surface observations, what a station model is, and then putting those on a surface weather map, and then forecasting. And that's it for Chapter 20. If you have any questions at this time, or something isn't, you need more help on something isn't really making the connection, please let us know. Love to help out.